Okay, so solving exponential equations typically involves trying to get the bases the same throughout. So what I mean by that is I've got 2 to the x there. 32 can be written as 2 to the power of 5. So if my bases are the same, the only way these two equations can be equal is if the powers are the same. So we call that, we don't cancel them, we equate. Okay, so we equate the powers, which means we let because the bases are equal, the powers have to be equal. So therefore we can say x is equal to 5. Do the same thing here. Let's get my x on its own. 3 to the x is equal to 162 over 2, which is 81. And again, 81 is equal to 3 to the power of 4. Bases are the same, so powers have to be the same. All right. So you can see straight away that there's only certain sort of expressions that we can solve without a calculator here. The right left-hand side, 2 to the 1 minus x. Let's simplify 16. It's the same as 2 to the 4. And if the bases are the same, the powers are the same. We can write 1 minus x has to equal 4. Therefore, x is equal to 1 minus 4, which equals negative 3. All right. We've got a null factor law here. So if we've got a product of terms equal to 0, that means that 2 to the x minus 16 is equal to 0, or 2 to the x plus 4 is equal to 0. So if I solve that, 2 to the x is equal to 16, 2 to the x is equal to 2 to the 4, therefore x is equal to 4, or 2 to the x is equal to negative 4. Now 2 to the x is greater than 0. So there isn't a value for x that will make 2 to the x negative, so there's no solution for that. All right, so the extension of that is, as bad as this looks, this is really just a parabola, or a quadratic equation, I should say. So if I let u equal 3 to the power of x, well, that means if I square that, I get 3 to the 2x. So really what we're saying is that's a u squared and that's u. So it's got a quadratic look about it. So then if I swap those around just to make it familiar, I can write that as u squared minus 12u plus 27 is equal to 0. And my factorising should hopefully give me negative 9 and 3. So u minus 9 and u minus 3 is equal to 0, which means u is equal to 3 or 9. Now u is something I introduced. Since u is equal to 3 to the x, I can replace that as, therefore, 3 to the x is equal to 3, or 3 to the x is equal to 9. So again, clearly, x has to equal 1, or 3 to the x is equal to 3 squared, and x is equal to 2. Okay? So they're my possibilities. So, look, these are the hardest ones, no doubt, but it's just recognising them. They've got a bit of a quadratic form about them. C is very similar. 4 can be written as 2 to the power of 2, all to the power of x, minus, well, that's the same as 2 to the x times 2 to the 3 plus 16 equal to 0. So that's the same as 2 to the 2x minus 2 cubed is 8 times 2 to the x plus 16 equal to 0. So again, if I put u equal to 2 to the x, u squared will equal 2 to the 2x. So subbing them in, I get u squared minus 8u plus 16 is equal to 0, which happens to be a perfect square. So u has to equal 4. U is equal to 2 to the x. Therefore, x is equal to 2. Okay, so certainly the first 4 examples I think are pretty reasonable. The last 2 take a little bit of thought, so you're going to need to practice those.